This is a video walkthrough of the code contained in the R basics file. To start off with, my R environment probably looks a little bit different than yours. I run dark mode. Your background is probably white with black text in it. If you wanted to change your background, you can go to Tools, down to Global Options, and then if you go to Appearance, you can, this is, what my current settings are, but if you wanted to change how it looks, you can pick any of these different options. And this is just visual difference. It does not affect at all how the code runs. So to start off with, the difference between comments and code. So this right here is going to be a comment. So a comment is going to start with a pound sign, a hashtag, the symbol, and it's a way of leaving notes to yourself. It's a way of leaving notes to other people who might run your code. And it's a really good habit to get into. So it's a way of describing what you're doing, why you're doing it. Code is going to look different from comments. And so the big difference between a comment and your code is that R knows not to attempt to run a comment, whereas with code, R is going to attempt to run it. Also, you don't have to have your comments only above the line of code. You can have it within the same line or in line. And this particular version is really useful when you have a multi-line block and you wanted to define what you were doing on each line. Something that we will be doing a lot of is using packages. So base R has a number of different functions and functionalities, but there are packages to extend base R's capabilities. They are a number of functions with similar functionality that are all packaged together. So to install a package, you will run the function install.packages and then open parentheses, and then you'll put the function or the package name, and then you'll do your closed parentheses. Make sure that your package name is in quotation marks. If you don't put it in quotation marks, R will get very confused and throw up an error message at you. To run a line of code, you can put your cursor anywhere on this line, and you can either come up here to the Run button with your mouse and click Run, or as it's showing you here, you can do Control Enter, and that will run your line of code without having to move back and forth between your keyboard and your mouse. So if I run this, we'll see down here in our console, excuse me, that R is thinking. So it's thinking about, this install packages ggplot2. It'll put up, these different things. Depending on the package, you might get a wall of text, or you might just get a little bit. And this is what you want to see. So package ggplot2 successfully unpacked. Great, now it's installed. This is just the install. When we want to use a package, we have to call it. So this is another package. This is tidyverse. And so if I wanted to use the functionality within tidyverse, but I've already installed it, I don't have to reinstall it. I only have to install it once on any given machine. But now I want to use it. And so I have to put a call to the package by using the function library, open parentheses, and then the package I want to use. You might notice we don't have to put the package name in quotation marks this time. So if I run this line, then we see again down here in our console that, library tidyverse. So it's thinking about it for a second because we don't have that sideways caret right here. And it's going to consider its life options. And here is the output. So this is just saying these are all the things we just pulled in. And it's saying, there are some conflicts, which basically means that some of the function names are the same as other function names. As long as you're aware of that, it's okay. It's not going to cause, major problems unless you're trying to use that exact same function name. So now that I've called the package, I've used that library function, I can then use the functions within there. But maybe I wanted to get some information about it. Maybe I wasn't sure what all was involved within this tidyverse package. So if I run a question mark followed by the package name, then I can get information about this particular package. And so what you'll notice is when I ran this, over here in this window is where the information pops up. So in this help pane, it'll automatically switch to this for you. It gives you a description. So tidyverse is a set of packages that work in harmony because they share common data representations. This is who maintains it, this is who contributes to it, and then here are some helpful links. So we could click on any of these if we wanted more information, if we wanted like a comprehensive list of all the functions. This is where you can get some more information about a package. Other things that you might want to do at the outset is set a working directory. So to set working directory, you would use the function setwd, WD standing for working directory. You would use the open parentheses, and then you would type your file path. So perhaps you have, a homework folder or even a homework 1 folder, and you have all of the code, you have your data set, you have your output, you have everything that you want within that same folder. If you set your working directory to that folder, it will make reading in your data a little bit easier. And so to set your working directory, you just put your file path. Depending on what it is, your file path will look a little bit different. And so you might notice that the double backslashes here, and that's just to let R know that this, the backslash is actually a thing that I would like you to read. If you only have a single backslash, it doesn't recognize it as a single backslash. We could get our working directory. So get WD, and we don't have to put anything within these parentheses. And it will print the working directory that it currently thinks it's working under. So it might be a good idea to set your working directory and then check it. So I think I set my working directory to my homework 1 folder, and now I'm going to get working directory just to make sure so it doesn't cause me problems later on down the road. R also has a number of built-in data sets, and this is to let you have a data set to explore some of the functionality. So one of the data sets that R has built in is something called women. That's just literally the name of the data set. So what we can do is if we just type in that name of the built-in data set and run it, it will print the output, it'll print the contents of the data set to our console. So we can see that it has 15 entries. We can see that it has a height column, and we can see that it has a weight column. We can also read in other file types. So built-in data sets are really great when we just want to experiment, but most of what we're going to be doing is on data sets that we need to read in. We might have Excel, we might have SPSS files, we might have SAS files, we might have CSV files. There's a variety of different files and files types that R is able to read in. Each one, though, might require a slightly different line of code in order to read it in. So one package that will be very useful is read XL. So again, if you need to install this package, this is how you would do it. This is how you call the package. So you say, I have installed it. Now I would like you to please use it. And then we can start reading in Excel. But we have to be careful about, for Excel in particular, is file extension. So this read underscore Excel function, you would use that same function, but you have to differentiate your file extension. So that's not something to be careful of. And what we're doing here is we are saying, will you please read in this Excel file, but then we'd like to do things to it. We might want to manipulate it. We might want to run statistics on it. We might want to run a t-test or an ANOVA or any number of things. So please read it in, but I would like you to assign that, that's what this little sideways arrow is, to this object. So we would read in that file, and then this is an object that we can then perform means, medians, ANOVAs, t-tests. We can do things on. So this is a common way of reading in data. So you read it in and you assign it to something. We can also, so this is when your file is within your working directory. You can also read in files that are in different directories. You just have to put the full file path. With Excel, since it has different sheets, you can read it in by sheet number. So if you have a file that has multiple different sheets, you can say, I would like you to please read in Excel. This is the file name, but I only want you to read in sheet number 2. I don't need sheet 1, 3, 4, 5. I just need sheet 2. You can also read it in by sheet name. So perhaps rather than just having different numbered tabs, it's easier for you to say, I would like the students sheet. Something to keep in mind is to make sure that you're matching capitalization. So here I have a capital S because for this particular Excel file, perhaps the sheet name with students has a capital S. If I were to use a lowercase s, R would not recognize that and would not read the file in. Other file types that we can read in are TSV files. So to read in a TSV or tab delimited file, we will need to install the reader package or readr package. We can also use this same package to read in CSV files or comma delimited files. So we would first install the package. If necessary, we would call the package, and then we can read in the files. So if we have a TSV file, we would use read underscore TSV and our file name. If we had a CSV file, we would use read underscore CSV and our file name. Here, we can specify whether or not that first row should be treated as column names. So by saying that call names, so call underscore names, column names, is false, we're saying that the first row is actually data. It is absolutely not column names. Please do not interpret it as column names. If we had column names equals true, then that would be saying the first row of our data is our column names. So that might be something like ID, student, class, score, test, something along those lines. So column names equal true would say, this is my column names. Please treat it as such. It is not data. Another way to read in CSV files is by simply using base R. So you can use read.csv to read in a CSV file as well. SAS files, SPSS files are both going to use the package Haven. So again, if you haven't installed it yet, you would install the package. If you have already installed it or you just installed it, you would then call the package. And you would read in the file. So you would use read_sas and the file name, or for a SPSS file, read_sav and then your file name. With all of these, notice how the extension, the file extension, is included in what you're asking R to read in. So make sure that you're being accurate with your file extension so R doesn't get confused and throw you an error. Also notice how we're always assigning it to an object. So that is something that you're going to want to do as well, is when you read in a data file, you're going to assign it to an object.